All right, this is the Honors Algebra 2 6.7 notes. So we're starting with these classified sets. So what we are doing here is we are determining, based on the table, is this linear, is it quadratic, cubic, exponential, etc. So what we're looking here is we're looking at the pattern and the y values. So the x values always must be evenly spaced. What I mean by that is, you notice these x values all go up by 1, versus down here, these x values all go up by 2. And so we don't care how they're changing, they just have to be changing the same way each time, so that it's kind of a consistent change. All right, so we're going to actually look at the y values and look for the pattern. So on this set of y values, I know that each time the y values are multiplied by 2. And you have to verify that it works throughout. So you times 2 each time, double checking there. 8 times 2 is 16. 16 times 2 is 32. So since it is multiplying by 2 every time, that is exponential. And so what we put down is, as x increases by 1, y is multiplied by 2. And this means it has a common ratio of 2, which means it is exponential, specifically exponential growth, because it's increasing. So if it's multiplying by the same number every time, then I know it is exponential. All right, now look at B. So on B, the x values are increasing by 2. So now we look at the y values. The y values are not multiplying by anything specific. I kind of look at this and I'm like, well, to get from 2 to 0, you'd have to times 0. That doesn't make sense to then times 0 throughout. That just doesn't make sense. So we learned this back previously. We're going to find the first differences. Remember, you take the right number minus the one just before it. So 0 minus 2 is negative 2. And then this one would be 2 minus 0. So take the right number minus the one just to the left of it. This would be 8 minus 2. This would be 18 minus 8. And so on. So let's see, we would get 14 here. And this one is 18 here. So this is the first time we did it. Remember that this is called first differences. Now, if these numbers were all the same, if they were constant, like they were all 2s or all negative 3s or something like that, then it would tell me since the first differences are the same, it has a degree of 1, meaning it's linear. Since they're not the same, I'm going to go ahead and do it again. So the second time I do it, it's called second differences. And I still keep that pattern the same where I do the right number minus the one just before it. So that's 4. 6 minus 2 is 4. 10 minus 6 is 4. 14 minus 10 is 4. 18 minus 14 is 4. So this is the second time I did it. So these are called the second differences. So since the second differences are constant, they're all the same number. So that tells me that it has a degree of 2. So because it's the second differences being constant, that tells me it is a degree of 2. And a degree of 2 is quadratic. Okay, if we didn't get second differences constant, I would do the third differences. If they were the same, that'd be a degree of 3, which is cubic. If they didn't work, I could try the fourth differences. If that worked out to where the fourth differences were constant, then that would be a degree of 4, which is quartic. Okay, so looking here, I can tell right here, if I know it's not dividing. And one way I can check to see if it's going to be like dividing by a certain number, I can take the second number divided by the one right before it. So I'm finding the ratio. So 9 divided by right before it. And so right there, do you see how those two numbers are not the same? So they don't have a common ratio. So I know it's not going to be multiplying by anything. So I can do 12 minus 15. That's negative 3. 9 minus 12, that's negative 3. And once they start to look the same, don't quit. Make sure it works out through the whole thing. So the first differences are constant. So that means it has a degree of 1, and a degree of 1 is a linear function. Okay, so on this one, I see on this one that it's dividing by 3, but you don't want to talk about it as dividing. You want to talk about it as multiplying. So it's timesing by 1/3. So every single time it times by 1/3. Now, if it was an obscure number like 2/5 or something that would be hard to tell visually, like in your head, you can always take the second number divided by the number right before it. And the third number divided by right before it, fourth number divided by the one right before it. Do you see how those are all the same? So that tells me that they have a common ratio. And the ratio is this, which is 1/3. And so that tells me it's exponential. So it has a common ratio. And so I know it's exponential. If they wanted it more specifically, because it's 1/3, I know it's exponential decay. All right. So writing an exponential function, so in this form, they give me 2 points. So from these 2 points, I'm going to make 2 equations. So I'm literally going to plug in x is 1, y is 6. So that's 6 equals ab to the 1, which is the same, right, as 6 equals ab. And then from this set of points, I'm going to do the same thing. I'm going to write 54 equals ab to the 3rd. I just substituted in x and y. Okay, so these are my 2 equations right here. So to solve this, I need to use substitution. So I'm going to rewrite this equation right here, the 6 equals a times b. I'm just going to solve it to get a by itself. So if I wanted to rewrite it and I divided by b, all I did was rearrange that equation. So I divided by b on both sides, so a equals 6 divided by b. Now, why I did that is because I'm going to take this 6 divided by b, remember it's what a equals, and I'm going to substitute it in for that a. So I'm going to have 54 equals, and then instead of a, I'm going to plug in 6 over b, and then I still have b cubed. So all I did was I rewrote the equation, so it's a equals, and I substituted that into the other equation. So I'm using substitution. So if you go ahead, you have 6, and then when you have this b cubed over the b, so right here with this b cubed over the b, that makes b squared. All right, and so from there we can divide by 6. We get 9 equals b squared, and we're going to square root. And when we square the 9, normally we get plus minus 3, but in an exponential function, part of the definition of the exponential function is that this b value must be positive, so we only use the positive 3. Now that I know b, I can go back into the equation, a equals 6 over b, and I can substitute the 3 in right there. So a is 6 over 3, which means a is 2. So my equation is y equals a is 2, b is 3, to the x. All right, let's go try another one of those. Okay, so looking at this, we're going to start with the first point. We're going to write an equation. So we have 12 equals ab to the power of 2. And then from the second point, go ahead and write an equation. So it's 24 equals ab to the power of 3. Now, I always go with the one that has the smaller exponent on b, and I'm going to solve for a. So if I divide by b squared, I'm rearranging that equation, and I get a is 12 over b squared. So then I use substitution, and I substitute this a value into the other equation right here. So what I have is I have that 24 equals, and then instead of a, I'm going to put 12 over b squared. So I'm just substituting that in. All right, so if you simplify that, when you have that b cubed over b squared, that just makes b. And so if you divide by 12, you get that b is 2. Now, once you have that b value, go back up and substitute it in here. So you have 12 over, instead of b squared, you have 2 squared. 12 over 4 is 3. So the a value is 3, so y equals 3. The b value is 2, so times 2 to the x. Okay, if you want to pause this video and do number 4, you can if you need the practice. I'm going to pause it and do it, and then I'll just show you the answer. So pause this video now if you want to do number 4, or just keep going through to the next problem. Okay, so here's my answer, and you can follow along with the work that we completed. All right, So our next topic is similar to the concept of writing an equation, but this is writing an exponential model, and specifically from this data. So it wants us to go ahead and write this model. So we're going to use a calculator to do this because sometimes when you're doing actual points, they don't just fit a perfect model. And so to estimate it, we have to use regression. So we're going to do stat. We're going to hit enter on edit. Anything in your list, go ahead and clear out. Go up to L2 and hit clear enter. And then go up to L1 and hit clear enter. I'm going to pause this video while I type in this data. Okay, so I had just typed in all of my data here. So when I go to graph, it may not show up depending on if your graph is really zoomed out. So I'm going to adjust my window. My window needs to go, my X values go up to 7. So I'm just going to let my window go to 10. Just give it a little bit of space. Then my Y values go up to 96. I feel like going up to 100 makes sense. So I'm going to go ahead and do that. Now I notice nothing's showing up here. What's going on is my stat plot's not turned on. So you can just go to Y equals and clear out anything you have in here and go up to where it says plot 1. And if you hit enter, it will turn it on. If you need more detail about what it's doing, you can always hit second Y equals. This is where all the information is about that plot. If I hit enter on this, it's on. I want a scatter plot. I can see X is L1, Y is L2. So now if I hit graph, it should be showing up. So that's clearly exponential growth. So to find this exponential function, I'm going to go do stat, go over to calc, and I want exponential regression, which if you scroll down, that is this one, exponential regression number 0. And so X is L1, Y is L2, go down to calculate. And so I can see my equation right here. Here's my A value. I'm going to call it 8.46. And my B value, I'm going to call 1.419. And then you can see my R squared is kind of a rating of how well it did. Anything close to 1 is very good, so 0.997 is excellent. All right, so remember that it was my A value was, let me go here real quick. Okay, so remember that my A value was 8.46 and my B value was 1.419. And keep in mind at the top of my graph right up here, or my graphing calculator, it says A, B to the X, so it shows me the format. So my equation is going to be Y equals 8.46 times 1.419 to the X. Okay, so then the second equation we have here says finding a logarithmic model. Notice right here, it tells you in this problem specifically that we're using natural log. So I'm going to pause this while I go and clear out my list. I'm going to type in the air pressure into list 1 and the altitude into list 2. Go ahead and do the same. Okay, so I have that all typed in, and it wants me to go ahead and use the natural log. So go to stat, go over to calc, and we want natural log regression. So if you scroll down, you can see that's number 9 is natural log regression. So I just go down to calculate, and so I find out that my, notice it gives me the format right here, A plus B natural log of X. So my A was 0.86. And then my B was negative 6.45, so I put minus 6.45 natural log of X. But then, of course, they wanted me to use H and P. So we're going to go ahead and our answer is going to be like this. And then it does also ask me to estimate the altitude, so that's H, when the pressure is 0.75. So I can just go in using my calculator and I can plug in 0.75 to this equation. And if I just go ahead and type this in my calculator, I get 2.7 kilometers. And so just using your equation to type it in.